Hello students, good evening. Yeah, it's already late. Why you are doing now? Super late. Yes. Hi, hello every students. Good evening. Just 2 minutes, guys. We'll start the session. Actually, small technical error. Yes. Hi, hello everyone. Welcome to the physics class, guys. This is Sham. Uh, in previous classes, we have started about the ray optics in refraction. No, today also we are talking about the remaining part of the refraction. Okay. Along with that, we are going to discuss few numerical problems also. And if we have a good time, means we will start the refraction through prism also today. These are the three concepts basically which I'm going to talk in today's class. Okay. Without wasting a time, we'll start our today's session, guys. Okay. Uh, guys, let me know my screen is visible properly, right? And my voice is also audible properly to all of you. Yes, good. And meanwhile, if you are getting any doubt, means free to don't just drop your text in a chat box. Okay, where you are getting a doubt. Okay, I will try my level best to solve your doubt. Clear, right? Okay, let us take a quick recall what we discussed in a previous class. In previous class, we start talking about the refraction through the curved surfaces and introduction to lens and types of lens and lens makers formula. These are all the things which we are discussed in our previous class. Correct है ना? Refraction through the curved surface में एक equation derive किया था हम correct ना? Just remember mu of a divided by u plus mu of g divided by v is equal to mu g minus mu a upon r. This is what the equation which we already derived in that form in that particular topic. Correct now? I told you guys here instead of mu a, you can write this one as an n1 also, and instead of mu g, you can write n2 also. Okay, both are representing the same physical quantities here. Clear? This is for when object at rarer medium. When object at rarer medium. Similar kind, if you're going to place the object at denser medium means, क्या होता है equation for the denser medium? कौन little change क्या करना है इधर Instead of mu A, we need to introduce here mu G. That's it. Correct now? Mu G by U plus mu A upon V is equal to mu A minus mu G upon R. ये right hand side term है ना, वो interchange होता है numerator में. Clear? This is what the equation. Later on, introduction to lens. Lens क्या होता है भाई? Actually lens है, it's a transparent material. Correct? Transparent medium bounded by two surfaces. Among these two surfaces here, one surface should be bulged one. Bulged or cave portion should it has. Correct now, because refraction should be takes place now for that reason. Those kind of a materials we call lenses. Right? Lens में two types lens basically we started, concave lens, convex lens. Correct now? Convex lens means here you may be observe here. Correct now what I'm writing in a red pen now here at the midpoint its size will be thick, at the edge size will be thin. Like this material we call convex lens. Convex lens may again three types: double convex lens and plano convex lens and concavo convex lens. Right? Hi, good evening. Good evening, Ashwini. Okay, coming to the next point is that concave lens. Concave lens क्या होता है? Property, physical property. At the midpoint it should be thin. At the edge point it should be thick. Like this material we call concave lens. Concave lens may be three types. First one is double concave, plano concave, convexo concave. Correct now? And then convex lens will form the real and virtual images, and concave lens it forms the always virtual images. Clear? Later on, next, next क्या किया था हम? Principal focus. Correct ना? This is a principal focus वाला, right? This is a lens. What kind of lens this is? Convex lens. Correct now? This is a convex lens. If you are going to consider object at infinity, means the light rays which are coming from the object which are parallel to this principal axis. Correct now? If they incident on this aperture, they all are meet at one point here after refraction. This is called the principal focus of this convex lens. From the optic center to the principal focus, whatever the distance is there, no, we call this one as a focal length F. Right here, the focal length, it is in the direction of incident light direction. That's why we are taking positive. And always the focal length for the convex lens is positive. Don't forget this one. Clear enough? Next बात है concave lens. Concave lens क्या होता है? If the light rays which are coming from infinity, if they are incident on the surface of the concave lens, actually they are get diverged. Correct now? In right side, these refracted rays, they never meet each other. Right? If you extend the refracted ray, means they will be meet at principal focus backward direction at one point. We call this one as a principal focus. But here from the principal focus to the optic center distance is there? No, that is focal length only. But this time the focal length we are measuring opposite to the direction of incident rays. That's why focal length here now negative. Clear now? Coming to the parts of the lens. This is a convex lens है ना? Convex lens का midpoint we call optic center, and for the first aperture it has an imaginary sphere right side. For the second aperture there is an imaginary sphere in a left side. दोनों को center होता है. That's why we call this one as a center of curvatures. Correct? From the optic center to center of curvature there is a distance. We call this one as a radius of curvature both the side. Right? And the midpoint of the optic center to the radius of curvature, center of curvature we call principal focus. Similarly for the concave lens also. Correct now? Right? And coming to the sign convention, there are same sign convention में कोई भी change नहीं है. All the distances we are measuring from the optic center only. That is a O. Optic center only we are measuring all the distances. Second most point is that in the direction of incident light direction. Light direction we will take positive distances. In the opposite direction to the light we are taking negative. Cool, right? Okay. Then after we derive one formula also, lens makers formula. Correct? Lens makers formula, what it gives actually as 1 by f is equal to mu g of a minus 1 into 1 by r1 minus 1 by r2. This is the equation which we got from the lens makers formula. Correct? Now we'll discuss further more about this formula. No worries. Up to this point, is there any doubt? Let me know through the chat box quickly. Hi Surabhi. Is there any doubt? Yes. Great. Okay. If there is no doubt, means I have a small question. Please do answer this question. What is the correct option for this question? Converging lens forms dash images. Quickly. Don't know how long the session will be go today. Actually, there is no power with my hand. What is the correct answer for this question? Simple say converging lens. Converging lens. देखो इधर converging lens यार. Converging lens is nothing but convex lens. Correct है ना? A optic center, a principal focus. I know converging lens always forms the real images. Real images. But one position is there. You might be studying in 10th standard. Correct now? Between optic center and as well as principal focus, if you're going to place an object, here means where the image will be formed. Look at here. First ray, which is parallel to the principal focus, means it will be move along the parallel to the principal axis, move along the principal focus. Second ray, if it is move along the optic center, means without deviation it will be go. For here, you may look here. These two rays, they are not yet interact each other in this portion. Then what we need to do? We have to extend these two refracted rays backward direction. Then it creates an image here of this object. Correct now? This image is an virtual one. That's why here the converging lens, it forms real images also and as well as virtual images also. Clear? Option C is the right answer. Is there any doubt? Is there any doubt? Yes, good. How was the physics exam today? That's great. Okay. Good. Shabash, at anyway. Next, lens makers formula. Actually, क्या था lens makers formula? Yesterday we derived, no? Yesterday I told, no, actually this is very important and we are discussing in a short method. I told this derivation lens makers formula, right? 5 marks question tha, right? I think for you it's a beneficial, right? कोई problem नहीं. Lens makers formula कैसे derive किया था हम? That is 1 by v minus 1 by u is equal to mu g with respect to a minus 1 into 1 by r1 minus 1 by r2. Correct now? Yes, good. Right here, what we consider actually yesterday I done this one with urgent. That's why today I'm going to explain one more time. Okay, this is our equation we got in middle. I call this one as a lens makers formula. What we consider here, if I'm going to consider the object distance at infinity, means where the image will be formed in a convex lens. Let me know through the chat box. Yes, right. Means if you consider this is a converging lens, convex lens means if object is at infinity, means the light rays which are coming They are parallel to the principal axis. This is the principal axis now. Where they actually converge at the principal focus, like this. Correct now? Here to here, principal focus. The distance we call focal length. Correct? The focal length it is the image distance hota hai then. Now substitute the value of image distance as a focal length. Then this equation will become 1 by f minus 1 by infinity kya hota hai? 1 by infinity. The total term will be 0 hota na idhar. Remaining term here mu g with respect to a minus 1 into 1 by r1 minus 1 by r2. This term will 0 means 1 by f is equal to mu g with respect to a minus 1 by r1 minus 1 by r2. This is what the equation which we will get to identify the lens maker formula. Or else then we want to know about the object distance and image distance and focal length distance relation means then you may type directly 1 by f is equal to actually this one. Correct now? 1 by f will be equal to 1 by v minus 1 by u. This is called the lens formula. Lens formula. Do you know one thing? Actually, there is a small clue between a lens formula and as well as a mirror formula. Mirror formula भी same होता है, but the sign between an object distance and as well as the image distance है ना, ये positive होता है. Yes, right. Cool. I hope it is understood, right? Has to stay. Yes. Right. Okay. If it is understood means I have one question here. Chota sa question. Let me check who will solve this question. Actually, this is a last year 2021 August JE paper wala. JE question. Simple. An object is placed at the focus of a concave lens. Concave lens. You need to identify the terms which will be come under the problem carefully. It's a concave lens where we place the object at focus, having a focal length f, focal length f itself. What is the magnification and the distance of the image from the optical center of the lens? Means we need to find out here what is the magnification. Means we need to compare the size of an object with the size of an image. What will be the size of image with respect to object? We need to explain. And second one, distance of the image from the optic center. Means we need to find out the value of magnification and then image distance. दोनों को calculate करना है. कैसे calculate करना है? Calculate meanwhile while I'm calculating here itself. If you're getting an answer faster than me means please do drop your answer in a chat box. Cool. Magnification क्या होता है? First topic. Magnification. It is nothing but height of the image divided by height of the object. Correct है ना? एक concave lens है. Always it forms the virtual image. Right? देखो इधर एक बार. Draw करो. Feel करो. Then only you will get the answer properly. Okay, we'll check your answer. Okay, इसका focal length है इधर, correct ना? This is the principal focus. Here to here the focal distance is f. Actually, object also we kept at the principal focus only. This is the object, correct ना? And then moreover, if the object will emits the light means first light ray will be move on along the principal axis like this in this way, and the second light I'm going without deviation it will be go like this. Second ray of light if I'm going to introduce here means incident here means it will be diverge in this direction. These two light rays will never meet each other right hand side. Then what we need to do? We need to extend backwardly this refracted ray. Then it will touch us here. दोनों reflected rays इधर meet होता है. Here it will create the image. One thing is find out image will be formed between optic center and as well as the principal focus. Correct now, but we don't know the distance. Now we need to calculate that. Height to pata nahi. Instead of height also we can calculate this one with the image distance by object distance magnification. No, correct ना. Image distance किधर बन रहा है? This side means we need to take negative sign. Object किधर रखा है? इधर. Light को opposite direction है. Object distance also. Then it is also negative. दोनों negative मर गया इधर. Then magnification आ रहा है इधर V by U. One more thing you clear from this point you clearly it is clearly identifies that magnification for the concave mirror it will be positive only. It is positive. Correct now. Later on, if you substitute the values means you will get negative answer also. No worries. But here it is clearly identifies that magnification for the concave mirror is positive. Cool. There is no problem. Substitute the values. First we need to find out the magnification. No, magnification के लिए image distance चाहिए. Image distance तो नहीं है. रख लो उधर से. Object distance कितना है? Object तो रखा है principal focus में means focal length में. Focal length f होता है. Now we need to find out the value of v. That's why v find out करने के लिए हमारा पास और एक इक्वेशन है लेंस मेकर्स फॉर्मूला में. करेक्ट ना. 1 by f is equal to 1 by v minus 1 by u. Either say we can easily find out the value of v. No, take v 1 by u to left hand side, then it will become 1 by f plus 1 by u is equal to 1 by v. ये सिंप्लीफाई करो. क्या होता है डिनोमिनेटर में fu डिवाइडेड बाय u प्लस f is equal to 1 by v. करेक्ट ना. हमको v चाहिए. Then do like this. V will be equal to change the numerator and denominator. Here fu divided by u plus f. रिवर्स कर दिया मैंने. That's it. Okay, next. फोकल लेंथ का डिस्टेंस क्या है? सब्स्टिट्यूट करो वो वैल्यूज को. फोकल लेंथ का डिस्टेंस क्या है? माइनस एफ. That's it. From the optic center to the object distance है ना, वो फोकल लेंथ. ये फोकल लेंथ है ना, उसको सबमिट किया. U का डिस्टेंस क्या है? That is also at a focal length distance only. Minus f होता है divided by u as itself. Object distance again minus f plus focal length again it is minus f. Correct now. Then it will become minus f square divided by minus f minus f. क्या होता है? Minus 2 times f. Minus f cancel हो गया ना. Is it right what I'm? Oh, okay. इधर वो small mistake हो गया. कोई भी पता नहीं. कोई भी नहीं बोला मुझे. यार ಹೇಳಲಿಲ್ಲ ನನಗೆ. Okay, देखो इधर. Yes, minus f. इधर multiplication है. Minus into minus plus होता है. F square होता है. But इधर minus f means it is minus 2f. Correct ना? 1f से 1f मर गया. Remaining thing will be f by 2 with a negative side. This is what the image distance. Look at here guys. Image distance क्या आ रहा है? Negative f by 2. Negative sign what it is indicating that it is also present in this direction only. देखो एक फिगर image का किधर बन रहा है? This is the image, right? The image distance also negative. It is showing, right? Confirm. Now substitute this image distance in this equation. One thing we got image distance. Image distance तो f by 2 है. f by 2 किधर है? एक ही among the option इधर है. Option number 3 में. Let us check the magnification. v का वैल्यू कितना है? Minus f by 2. डिनोमिनेटर में f है. करेक्ट ना. f कैंसल हो गया. रिमेनिंग थिंग विल बी 1 by 2 minus 1 by 2. Correct now. Here look at here. Magnification I already told you. Take magnitude 1. It will become 1 by 2. Correct now. Means magnification हो रहा है and image distance हो रहा है minus f by 2. Means which is the correct option among this 4? Option number 3. Right. Simple सा question था. Correct. Is any doubt? Srishti, Surabhi, Ashwini, let me know. Is it clear? Yes. Screenshot ले लो, or is no problem. I will send this PDF in a class. Sorry, group. Okay. Then we'll move to the next one. Our question. Curved surfaces. There are two curved surfaces in this figure. Okay. Plano convex lens of refractive index mu1. Look at here. This is a plane. This is convex surface. This is a plano convex surface and plano concave lens. Sorry, second one. This is a plane and then this is a concave lens. Correct enough? Of refractive index है mu2 are having equal radius of curvature. दोनों का radius of curvature equally है. Okay, shown in the figure. Find the ratio of radius of the curvature to the focal length. Means we need to calculate here the ratio of radius of curvature to the focal length. This is what the question. Magnification means we need to just analyzing the size of an image to the size of an object. That's it. We are measuring the length of the image by length of the object. So you are asking by doing experiment. Cross check once what you are asking. Okay, we'll solve. Actually, this is a plano convex and as a plano concave. Like this materials are there. This is a convex one, and second one is plano concave lens. Right? Here the refractive index of the plano convex lens is mu1. Refractive index of the plano concave lens is mu2. We need to find out the ratios right here. Before that, guys, let me know which formula we can take here to solve this question. Is there any idea? Here we need to find out the ratio of radius by focal length. Where we can get this two physical quantities in single equation. Yes, right. Right, obviously right, Surabhi. Right. We can take from the lens maker's formula. Actually, lens maker formula kya kehta hai? Actually, the lens maker formula 1 by f is equal to mu g with respect to a minus 1 into 1 by r1 minus 1 by r2. Correct? Now, this is what the main equation. If you consider here plano convex lens hai na, first term is that convex lens. This is the first aperture of the convex lens. For this aperture, there is a fixed focal length. Correct now? Imaginary sphere will be present here. For that reason, there is a fixed focal length for this aperture. But what about for this plane? इसको focal length क्या होता है plane को? Is there any limited one? No. Correct now? That day only I told you. No, actually उसको the radius होता है infinity, or else we can call this focal length of that will be infinity. Correct now? That's why you take only one thing here. R1 you take from this one. Okay. Similarly, if you're going to write for the second one also, concave surface के लिए हमको मिलता है radius. First one. For the plane के लिए again it will be infinity. Correct now? That's why what I will do here. First, I will write the equation for the plano convex lens. For this surface, I will write 1 by f is equal to, simply I will write mu minus 1 into 1 by r. Correct now? 1 by r. We can write 1 by r1 also, there is no problem. Just I will write 1 by r. Why I will tell you later, because they said here they have equal radius also. Correct now? Similarly, this is a mu1, right? Refractive index, right over. Second one, 1 by f is equal to mu2 minus 1 divided by r. Correct now? दो equation मिल गया. Now what we can do here? Actually, just remember when I'm explaining the combination of focal length for the lenses or mirror. Okay, I told you that if the combination of lenses are same like this, same combination होता तो इसका focal length क्या होता है? f1 plus f2 होता है. Add करना है 1 by f1 plus 1 by f2. We'll do same thing here. Okay, we'll do same thing here. Let us check what will be happen. 1 by f1, but it is opposite direction. No, that's why minus 1 by f2, left hand side wala. Right hand side में mu1 minus 1 by r minus mu2 minus 1 by r. Correct है ना? Right, what I'm saying. And what it will give? Actually net focal length it will give. Right, that's why I'm writing this one as an 1 by net focal length is equal to, ये दोनों term में we can take r as a common. Right, if you take r as a common means 1 by r. The remaining thing is mu minus 1 minus of 1 इधर minus mu2 minus 1. Correct है ना? Right, take this r to left hand side. I will write this formula in the next page. Stay connect here. Okay, इधर जगह नहीं है, क्या करना है हमको? New page लेना है ना? Okay, I will take a new page. Okay, I will write here. देखो इधर 1 by f net. Okay, 1 by r mu1 minus 1 minus of mu2 minus 1 था. Correct now? Take this r to left hand side. Then it will become r divided by f net is equal to, f net means focal length of the combination of lengths will be equal to mu1 minus 1 minus into plus minus mu2 minus into minus it will plus 1. Correct now? Plus 1 minus 1 cancel हो गया. What we actually we need to calculate radius by focal length. क्या होता है इधर? Radius upon focal length will be equal to mu1 minus mu2. मिल गया हमारा आंसर. Correct now? Take this screenshot, guys. This page will not come in a PDF actually. Right? Are you got the answer, guys? How I solved this one? Let me know through the chat box. Yes. Good. Hence, correct answer for this question will be. Where is the correct answer? Option 2. Correct. Option 2 is the correct answer. Just cross multiplication. Clear enough? Right. Awesome. Awesome. Okay. These two are the questions which are asked in the previous year JEE paper. Okay. And I will give you a few homework problems also. I think around 6 to 7 are there. Try to solve these all the problems. Okay. If you're getting any doubt means tomorrow ask in a class. Okay. These are all the questions. Okay. They are all homework problems. I will send you through the WhatsApp itself. PDF बनाकर देखते हैं. This is also homework. Okay, let us discuss the prism. Prism क्या होता है actually? Correct है ना? While studying this prism, we'll look into basic simulations also. It will give some idea about the prism. Okay, prism क्या होता है basically? Anybody? It's a triangle one, right? How many edges are there in a prism? 3 edges. 1, second, third. Correct? Is three edges are present in a prism? Three edges are present in triangle, not in prism. Actually, this is a one dimensional figure है ना, इसलिए ऐसे दिख रहा है. करेक्ट ना? प्रिज्म अलग होता है, राइट? एक्चुअली प्रिज्म having 5 faces, right? Among the 5 faces, one is base. Actually, base will be here, BC. Here it is base. Okay. Second one is, okay, one is base. Remaining 4, no. Out of 4, 2 are refracting surfaces. Refracting surfaces 3 हो गया, और 2 बचा है ना, वो कहाँ होता है? और 2 है ना, they are the faces, correct ना? Front and as well as back faces. 2 faces, right? Totally 5 faces are there, right? Among that one, first one is base. Base we can call here BC as a base. This B and C is there, no? We can call this one as a base. BC. Refracting surfaces means here you may look AB is there, no? We can call this one as a refracting surfaces, and as well as AC also refracting surfaces. 2 faces means this front side दिख रहा है ना आपको एक कलर में, हम meaning green color में. Okay, this one face, exactly another opposite side आपके तरफ. Okay, एक face है, वो भी एक होता है. Okay, 2 faces होता है. Clear? And moreover, next point in this figure is this angle. This angle is there, no? We call this angle as an angle of the prism. Angle of prism or refracting angle. Refracting angle. Right? This is all about basic idea of the prism. Guys, you know already about this one. Actually, you are handling this optical instrument or optical material in a laboratory. Correct now? It is enough for you all. क्या होता है ये prism के? Now we need to study about the phenomena when we are incidenting any light ray on this prism. How the light ray will be get refracted, and by the refraction process, by this phenomena, how we can calculate the value of refractive index of this medium. कैसे calculate करता है? In that way we are going to deal in this. Correct? Before that, I would like to take a simulation, guys. Just be with me here. Guys, let me know if my screen is visible to everyone. Actually, I opened one page, web page. Is it visible? Right. Now, is it visible again? Sorry, I'm disturbing you. Just actually, there is laser light है. दिख रहा है ना? Yes, awesome. It's fine. Okay. देखो इधर so many optical instruments are there. I would like to take this prism. This is a prism. Tanna sa munna sa prism है. Correct है ना? Refractive index in right. Okay. I'm placing this is my क्या बोलते हैं इसको? This is our laser light, which emits the monochromatic light and as well as white light also. White light कैसे? Don't ask. Actually, this is a C programming what they did here. By this laser only we can emit white light also here. Source, yes, sorry, right, source. Okay, now I will on the source. Okay, look at here, the light ray which is traveling actually straight line. Correct, Anna? Now what I will do, slowly I'm going to increase my angle of incidence here, means on the prism. देखो उधर कैसे bend हो रहा है, correct है ना? First, this is the first surface. In first surface, when light will be incident, no? If you draw a normal line, I will explain in a PPT presentation also, no worries. If you draw the normal line, means it makes an angle of incidence here. Again, it will be refract in this denser medium. And further, when it is coming from the second surface to the air medium, again it will be get refracted, right? And this is a final ray, which is you are looking in the right side, correct now? This ray we can call this one as an emergent ray also. Clear? This is what the phenomena, how the light will be get refracted. Just you look at here. Hey, क्या हो रहा है आपको? Okay, this is air medium. अरे यार, why? Huh, now it is fixed. Okay, if I'm going to take the beam of light, look at here. All the rays which are incidenting on this prism now, they are parallelly incident and parallelly they are emerging here, right? Each ray incidenting rays are parallel, means they are emerging also here parallel. Okay, and coming to the white light, yes, देखो इधर, I'm going to already told you I can incident from this laser white light also. Here it is passing white light. Look at the right side. It is splitting the 7 colors. We call this one as a dispersion. We'll discuss that one in a classroom itself. No worries. Correct now? Okay. Next thing. This is a base of the prism. Look at here. If I'm going to just a minute. देखो इधर carefully. Now I'm going to increase the incident angle. Hey. Okay. Now I will increase the incident angle. No, it will not prove. क्या हो रहा है इधर मेरे साथ? हाँ. Okay. Look at here. Incident angle को increase कर रहा हूँ मैंने. Refraction angle क्या हो रहा है? ज़्यादा हो रहा है. Look at here. First इधर था, right? If I'm increasing the incident angle, means refraction also ज़्यादा हो रहा है. Correct ना? Deviation angle क्या होता है? I will explain that one also. Normal PPT. No worries. Here it is not coming properly. Okay. This is the first prism refraction. If I'm going to take another one prism here, क्या होता है then? देखो इधर. This is also prism. Correct now? If I place together like this, it is not actually binding properly. Yes, कोई problem नहीं. देखो इधर. This is the emergent ray. Right side may you may be observe this one. This is the emergent ray. If you extend the incident ray, means it will come here. Extended incident को emergent ray कैसे हो रहा है? Parallel हो रहा है. Means it is now it is acting like a glass slab. Correct. It's acting like a glass slab. Next, if I'm going to introduce one more prism here, means again it is acting like a prism. Correct now? Where it is prism? Actually, prism is not there, sir. You might be asked the question like this. The prism means it should be three edges. Here, front face में 3 edges होना, but either 1, 2, 3, 4 are there. How it will become prism? No worries. Take one more prism and join here. Now it become a prism only. Correct now? This is half of the prism. Half of the prism में prism तरह में act होता है. Clear? These are the basic ideas. Okay, if I'm going to change the color, means हाँ देखो इधर, देखो it is very important. It's a red color. If I'm going red color having a maximum wavelength, देखो इधर 700 nanometers showing. Correct now? If I'm going to keep on decreasing the wavelength, refraction angle क्या होता है? देखो इधर डाउन चल रहा है वो ray of light. Observe करो. Do observe. Correct now? Do observe this one. Right? It means that the refractive index depending upon the wavelength also here. Correct? These are the quantities which we are analyzing through the prism concept. Okay, this is all about this simulation. We'll wind up this one. It's enough. Okay, मजा आ गया ना? एक बार बोलो मैं चैट बॉक्स में, कैसा था सिमुलेशन? आर यू देयर? Yes. So stay Surabhi, where you went? Okay. Guys, let me know my screen is visible right now. Yes. Cool. Right. Right. Angle of prism. Angle of deviation को calculate करते हैं first itself. Okay. This is a prism, guys. In this prism, sides A, B, C. Sides means here is corners there. Okay. Sides means don't think like that when you are taking a photo. Sides means open kai like that. Apla. They are not the sides here. Okay. Sides means here A, B is a side, AC is a side. Okay. BC is the base. Okay. Let us take a ray. I'm going to incidenting one ray like this. This is an incident ray. At the point of incidence, we need to draw a normal to the surface AB. This is a normal. Between this normal and as well as incident ray, whatever the angle will be created, no, we call this one as angle of incidence. And further, actually, it has to go in this direction. This is what the original direction of the incident ray. But due to the introduction of the medium, mu, क्या होता है? Refracts होता है, and here for the surface BAC, this ray is a incident ray. At this point, we need to draw again one normal perpendicular to AC, and again for the second surface AC, this is the extended incident ray. Ray इधर चल रहा था, but due to the medium, air medium here it will be moved away from the normal. Correct now? This is a normal, away from the normal it will move. Here क्या होता है? This is a emergent ray basically. This is an emergent ray. Correct now? This is incident ray. This is the angle we call emergent angle. We can denoting this one with a I2. This is I1. Guys, quickly do participate in NPS poll. Actually, my lap is running with a low battery. I don't know on what time it will be shut down. Okay, please do give your NPS awards here. Yes, awesome. Don't know when it will be switched off. This is the emergent ray. Now we need to find out the deviation angle. Deviation angle क्या होता है actually? Refracted angle से emergent angle between the angle. Correct ना? For the first surface refraction किधर हो गया है? इधर. This is what the refraction angle. We can take this one as an deviation angle. Correct ना? Here 2 times refraction हो गया. For the second surface refracted ray here. Okay. From the refracted ray to extended incident ray, here it is. Correct now? This is what the extended incident ray. Between these two angles is there, no? This is also deviation. That's why I will call this one as delta 1. This is a delta 2. Means we need to write the deviation for the prism. Total deviation क्या होता है? It is sum of 2 deviations. Delta 1 plus delta 2. Delta 1 value क्या है? देखो इधर. सुनो. This is the angle of refraction. Sorry, it's not visible, right? This is the angle of first refraction. I will call the refraction number 1. This is the second one. I will call, sorry, this is the incident ray. I'm going to call this one as an R2. Correct now? हमको क्या चाहिए? This angle चाहिए. कौन से angle? Where is my cursor? Let's see where it is. This angle we need from the refracted ray to extended incident ray. How we can calculate? What is the value of delta 1 now? Tell me by this figure. Take this one as an P, this one as an Q. Then delta 1 value क्या होता है? देखो इधर. ये टोटल एंगल है ना, ये टोटल एंगल I1 होता है, इधर से इधर तक I1, करेक्ट ना। ये स्मॉल एंगल चाहिए मीन्स I1 में R1 को माइनस कर दो, देन डेल्टा 1 विल बिकम I1 माइनस R1। सिमिलरली डेल्टा 2 क्या होता है, ये I2 होता है टोटल, एंड R2 को माइनस करना। Hey all, I'm audible, right? Ashwini, do text me in the chat box. Yes. Okay, we'll continue this one. Okay, we'll finish this one. It will be helpful for tomorrow class. Okay. So now delta 1 value क्या मिला हमको? Deviation for the first one, I1 minus R1. For delta 2, it will be I2 minus R2. Correct ना? Substitute these two values in this equation. Delta will क्या होता है इधर? I1 minus R1 plus I2 minus R2. ये दोनों इक्वेशन में एंगल ऑफ इंसिडेंस को ऐड करो, डेल्टा इज इक्वल टू I1 प्लस I2, ये रिमेनिंग थिंग हियर R1 R2, ये दोनों टर्म में वी कैन टेक माइनस एज एन कॉमन, देन ऑनवर्ड्स R1 प्लस R2 होता है, करेक्ट ना। दिस इज द बेसिक इक्वेशन फॉर द deviation. We can simplify further this one. How to simplify this one? Actually, we need to note down the values of R1 and R2. R1 क्या होता है इधर from this? If you're going to take the triangle here, triangle APQ, where it is actually APQ. In this triangle, this is the angle A. We need to find out the angles, these two angles. A का angle पता है, A itself is the angle A. Okay, ये angle क्या होता है and ये angle क्या होता है पता करना है। P के साथ रिफ्रैक्टिव एंगल है ना, इसको कैलकुलेट करने के लिए मैंने क्या कर दूंगा, इस सरफेस से इधर तक नॉर्मल तक एक परपेंडिकुलर लाइन था, इधर देखो इधर, दिस इज ये, दिस इज रिफ्रैक्टेड रे, Actually, this is a normal ray. देखो, so this is normal, this is refracted ray. From the from the surface of AB to normal ray, I will write a, I can write this one as a 90 degree. Correct enough? But we know this angle, that is R1. Then this is total 90. हमको चाहिए A angle. क्या होता है? 90 में R1 minus कर दो. Correct ना? This is what the angle of P here. From triangle we can write A plus angle A plus angle P plus angle Q is equal to 180 degree. Angle A क्या होता है? A itself plus angle P क्या होता है? Right here 90 minus R1 plus similarly angle Q also if you calculate means it will come 90 minus R2 is equal to 180 degree. Either 90 plus 90 180, either 180 cancel होता है. Correct ना? Remaining thing A plus either minus R1 minus R2. We can here also we can take minus as in common. If you take minus as in common means we can write R1 plus R2 is equal to nothing is there 1. Correct now? If you take R1 plus R2 right hand side, then it will become A is equal to R1 plus R2. Correct now? Value of R1 plus R2 क्या होता है? Angle A को equal होता है. Then we can replace here delta is equal to I1 plus I2 minus A. Correct now? This is the equation for deviation through the prism. Clear? Right. I hope it is clear up to now. There is no doubt. हाँ, और एक small concept, एक छोटा सा concept है. सुनो इधर. Actually, I told you no. That's why I'm explaining this one. This is the incident ray. This is the incident ray. This is what the incident angle I. This is refracted first ray, and for the second surface again it's a normal. This is also normal. From the surface it will be refract. This is the refracted ray. This is incident ray. Or else we can take this one as an emergent ray also. Either I1. This is I2. So note carefully. First, if I'm going to incident the ray at this point, है ना? Angle of incidence क्या होता है? ज़्यादा होता है. For that reason, I will take just a minute. What I will do? Normal है ना? Normal से angle of incidence. Okay. If I incident the ray here, it will become angle of incidence. At the time, refracted ray किधर चलता है? Towards the normal only. Here it will go, and further it will move away from the normal. Angle of incidence ज़्यादा होता है. Means deviation angle ज़्यादा होता है. Correct ना? If the angle of incidence is small, first case में deviation angle is bigger one. Correct ना? If I further increasing the angle of incidence in this direction, angle of incidence को increase कर रहा हूँ मैंने, right? If you increase the angle of incidence means this ray will be keep on going like this. Means क्या होता है? Deviation angle decrease होता चलता है initial में. If you increase the angle of incidence, right? Deviation angle will be decreases. Up to what point? Up to I1 angle of incidence. Some one point will be मिलता है. I1 will be equal to I2. At this condition, up to this condition, if you increase the value of angle of incidence, deviation angle decreases. Further, after reaching this point, further if you are going to increase the angle of incidence, the deviation angle will be keep on increases. Okay, we need to represent this one in a graph mode, right? That's why I stopped here. Here I will take angle of incidence along the x-axis and deviation along the y-axis. Okay, na? Now, first angle of incidence minimum tha na, that time deviation angle maximum. I'm marking here, deviation angle is maximum. If you keep on increasing the angle of incidence along the x-axis, deviation should become down, 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 down like this. At one particular point, at this point क्या होता है, angle of incidence angle of emergent को equal होता है. After this, if you further increase the angle of incidence, क्या होता है, deviation angle also keep on increasing like this. This is what very important graph. Okay, it will give the idea about the incident angle and as well as the deviation. Clear? Is it clear? Cool. Okay, this is all about today's class. We'll meet in a tomorrow class. Okay. No. It will not happen like that. I will send you some simulation. You can watch there, or else I will I will give the answer you. Okay, no worries. Okay. Okay, we'll meet in the next class. Until then, take care. Bye bye.